All right, now, guess what? Now we're going to deal with expanding the power rule to any arbitrary real number as an exponent. So we're going to take this, y equals x to the r power, where r is now, again, any arbitrary real number. And so what we're going to do is we are going to derive the power rule using logarithmic differentiation and watch what we get. So now, all I'm going to do is I'm going to take the natural log of both sides. So I get the natural log of y equals r times the natural log of x. And so again, this is much less complicated because I don't have anything other than x, right? So now what happens is, what's the derivative of both sides? Well, this is going to give me 1 over y dy dx equals, now here, this is just an arbitrary real number. And so I can just pull this out. So this is going to be r times the derivative of this, which is going to be 1 over x. Okay? Now I'm going to multiply both sides by y. So I get dy dx equals y times r times 1 over x. Okay, now I'm going to substitute y back in. Well, what's y? X to the r. And I'm going to rearrange this. So this is x to the r times r times 1 over x. Oh, hold on a second. Oh, yeah. So now, what happens here? Well, I'm going to rearrange things. So this equals r times what? X to the r over x, which equals x. Well, properties of exponents, I get x to the r minus 1, and I'm done. So I just showed that you can use the power rule for any exponent r. So this works for any real number, but you have to use, to prove it, you have to use the logarithmic differentiation. But now you can use the power rule for any power function that has any exponent, any real number exponent. That's it. Have a great day.